So for number one, we're going to start off doing the antiderivative. So antiderivative of sine is negative cosine. Then we're evaluating that from 1 to x. So we're taking the derivative of negative cosine of x minus negative, so plus cosine of 1. What's the derivative of negative cosine? Sine. Derivative of cosine of 1, well, cosine of 1 is going to be a constant, so derivative of cosine of 1 is going to be 0. So we just end up with sine of x. So again, I'm not going to ask you to show the work on these all the time. In the future, for this problem, you can just use that shortcut. Derivative of this definite integral, we're just taking this x, plugging it in for t, replacing t. But remember, it has to fit that format. It has to go from a constant to x for that to work. So with that being said, let's look at number 2. Is this going from a constant to x? Not so much, right? So right now, the way it's set up, we can't do the same thing we did in number 1. We can work it out, but we can't do the shortcut aspect of things the way it's set up. So we need to switch 3 and x, but if we switch these, what happens?
You have to switch your something.
You have to switch your something.
I remember this. Oh my god.
What happens if we switch a and b?
Negative.
It becomes the opposite, right? Remember, we switch those around, it's going to give us the opposite answer. So to kind of counterbalance that, we put a negative on front. That keeps it the same. So we're doing the definite integral from 3 to x, but it's going to be a negative out in front of there. And then we have the square root of t cubed plus 7 dt. So now we have a constant to x. So it fits that format, fits that theorem. We can evaluate this one using the shortcut. Basically, all we're doing, derivative of this, the negative is going to stay out in front, and we're taking the x, putting it in for t. So we end up with negative square root of x cubed plus 7. That's it. Now, we don't actually have to do the antiderivative and then do the derivative, evaluate. We don't have to do all of that. We can just use that shortcut. Yeah.
Right, so the reason why you flipped it was in order so you get the x to plug into the...
Yeah, we need to have the constant first in order to match up with our theorem here. The constant has to be first, and then we have to have the x up top.